As we discussed in the last video, we are now going to try and quantify the concept of chance. What is the likelihood or the chance that a certain event is going to occur? So this is a thinking lesson. We're going to go to a little bit of theory, but please make sure that you pay attention to this. This is extremely important. I'm only going to cover the concepts which are essential for a practical use of probability. No useless theory here. Everything is going to be very practical, and each concept that I cover here is going to have an impact on your ability to solve real world problems in the future. So let's start off with a very simple problem to try to convey why probability is so important. So I've removed some of the calculations over here because we're going to come back to this later on in the course, but I want you to take a look at this problem. So there is a disease which occurs in only 0.2% of a population, right? So whatever disease that is. We have a test. So these are the statements that are given to us. These are facts. And we are going to create an argument based on them. So we have a test that given to a sick person gives a positive result 85% of the time. So it's not a bad test. Of all the people ever tested, 8% were positive, right? So that is another piece of information that is given to us. Now here's the question. If a specific person is tested and the test comes back positive, what are the chances that this person actually has the disease? This is the information. This is all the information that you have. Now, what is your intuition? What do you think the chances are? So if it was me, I would not say 85% because then this question wouldn't really make sense. I mean, what's the point then? I'd say like 77% probably, right? So I'm just going with my gut. I'm not really sure what the correct answer is. And that is the whole point of this example. That if you don't really understand the concepts of probability, if you do not be rigorous with them, if you're not mathematically accurate with them, then you can make a mistake that is huge. So this is a problem that you can think this is a very common real world problem, right? Real life, God forbid, there is a problem and then you go, you have a test and the doctor tells you all of this information and then they tell you that you're a goner now. You have a problem. You need to fix yourself, right? And they give you a huge bill. So you get worried. So what are the chances that you actually have that disease? So pause and think about this. See if you can work it out on your own from your intuition. We're not going to actually do the calculation for this, but I'm going to tell you what the correct answer is. And when I first saw this example, it was really shocking to me that the correct answer over here is actually just 2%. That's the correct answer, just 2%. Given that the test comes back 85% of the time, it comes back positive if given to a sick person, and all the rest of the information, right? So the correct answer is the actual chances of this person actually having the disease is just 2%. And I want you to take this throughout the course, that whatever your intuition is might be really wrong. And that is why you need to be rigorous about this and do actual calculations before arriving at a conclusion. So I hope that motivated you. Now we are going to go back to the actual task of quantifying chances. So we're going to start off with a very simple example, and that is that you are going to flip a coin and I'm going to ask you a question. The question is, this is the question: what are the chances that it will land on its head? Now this is an extremely difficult question, right? So this question is extremely hard. Why is this hard? Because what are the chances? You have to think about air resistance and the mass of the coin and how you flipped it and how high it went and a lot of factors, right? So you can probably argue with them, but the chances are very difficult to quantify. There is a related question, which I'm not asking right now. I'm going to come to this. That related question is, if I flip it 10 times, how many will be heads? So that's an easy question. You can just flip the coin 10 times and you have the answer, right? So this is an extremely easy question. What we want to do is somehow in the future at the end of this course get to this hard part, but we are going to start with this easy part and we are going to make some assumptions. So first note that we are flipping a coin, and this seems like a very simple example that everybody does in a probability course. But in this course, I am going to give you a very small extra tip that is going to turn this on its head. This is going to make this very simple example extremely important. Think of it this way. A head and a tail, these are just two outcomes. Being a computer scientist, from the words just two, you should be thinking of a concept that you have studied all your life, which is binary. So think of them as 0 and 1. What are the chances that the bit is going to be 0 or it's going to be 1? If you think of this as 0, 1, this is really going to change your perspective of whole probability, and we're going to come back to this again and again. Now, the event that when you flip the coin, it comes up tails is one event, and another event is that if you flip the coin, it comes back heads, right? So these are our two events, and these are the only two events that can occur. Now, because we're not trying to answer this hard question, I'm going to tell you that the actual chance of it coming up heads is 0.5 or 50% or half the time, right? So we are going to start with this basic concept that in our whole universe, which means everything that can happen, so everything possible, that is called our universe. Make sure that you understand this. Like I told you, we are going to come back to this again and again. So this thing is called our universe. So that is our universe. There are only two events in this universe. One is that it comes up heads, and the other is it comes up tails, and their chances are equally likely, 0.5 and 0.5. Now this is called a fair coin. It's not necessary that the coin is fair, but this is a fair coin. Okay. Now chances of it being heads is written like that. So P of H, and this is read as the probability that it comes up as this event is 0.5. Now we are not going to use the word chance, we are going to use the concept of probability. Similarly, the chance or probability of it being tails is P of T is equal to 0.5. Now, because probability is mathematics, it needs to be based on some foundational mathematical principle. These are called axioms. So if you already know what axioms are, fine. But if not, I'm going to give you a brief overview. So whenever you do science, you have some sort of foundational rules on which you work, right? These rules are derived from some other rules, and those are derived from some other rules, and so on and so forth, just as you do in algebra, right? So in order to prove something, you start from the basic concept of addition, subtraction, division, multiplication, and you arrive at higher concepts. But at the base of everything, there is always some rules which do not have any proof. Those rules are just accepted by everybody who works in that field. These rules are called axioms, right? So you might be thinking, well, science is all about objectivity. Where did this agreement came from? That is necessary. Whenever you start the scientific method, at the foundation, there is always going to be some axioms. Now, it seems weird, but consider the axioms of probability and you'll see that yes, they make sense. We are only going to take a look at two axioms of probability. There are actually three, but we are only considering two over here. The first one is that the probability must always lie between 0 and 1. Now we picked these numbers out of the blue. So we could have said that they must lie between 0 and 100. But everybody agrees that we are going to use 0 and 1. Right? So they could have been any two numbers. Everybody agreed on 0 and 1. Why? Because 0 means it cannot occur. 1 means it definitely will occur, or it definitely has occurred. Right? So that covers everything. So when people say, I'll give it my 110%, it doesn't really make any sense. Okay, so you cannot go beyond 100%. The second thing is that the sum of all events must be 1, which means that if only two things can happen, the chance of one happening plus the chance of other happening, it must sum to 1, right? Because those are the only two things that can happen. Nothing else can happen. If it can, then it's another event, right? So I'm sure you'll agree that these make sense, right? So because they make sense, everybody agrees on them. We are going to build everything that is probability related on top of these. So if anything violates one of these two, we will not be able to call it probability. For instance, if you say that the probability of heads is 1.2, then this is not probability. You cannot call it probability. You can call it something else. You can come up with another theory, but you cannot call it probability, right? So please make sure that you understand this. This is actually going to have an impact on the models that we create. Similarly, you can say that probability of heads is 0.7 and probability of tails is 0.2, and these are the only two things that can happen, the only two events in our universe. Then this also cannot be called probability because it violates axiom number 2. Okay, so these are the two axioms that you must keep at the back of your mind always. So if you do some calculation and your probability comes out at like 1.1, it's wrong. Okay, so now because we have a foundational understanding of one flip, now we can reason with two flips, right? So here's the idea. You flip it twice. there are four possible outcomes. The first one is heads and the second one is heads, heads and tails, tails and heads, tails and tails, right? So hold on a minute over here and think about this. Is there something that is similar to this concept of this combination that we're seeing? Have you seen something in computer science that looks like this, right? So truth tables, right? So they look like that, 0 0 0 1 1 0 1 1, right? So they look like that. So keep that at the back of your mind. Now, if these two flips are independent, again, we don't know what independent means at the moment. Essentially, think of it this way. They don't affect each other. Okay. So probability of heads, heads. So this is what it's saying. What is the probability of this guy over here? So because they are independent, we can say that heads, 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 tails, tails, heads, and tails, tails, they are all four equally likely in our universe. The whole universe, the probability of the whole universe must sum to 1, and because they are 4, all of them equally likely, we divide that 1 into 4 parts, so we get 0.25 in each. Another way of measuring this is number of ways that an event can occur, the event that we are interested in. So this is called a favorable event, right? So the probability of favorable event is the number of ways that this favorable event can occur divided by all possible outcomes. So probability of heads, heads is this guy 1. So this guy over here divided by 4 is equal to 0.25. You can also write it as 25%. Now what we're going to do is we're going to stop a little bit, and in the next video we are going to try and derive the same number, not from this rule that is written in a textbook and we just have to accept it. We are going to see how people come up with this, and this is going to give you an intuition of how mathematics really works. So one of my aims from this course is not just to teach you probability, but to teach you how to learn any sorts of mathematics. How do people do maths? Right? So that is one of the objectives I have from this course. So in the next video, we are going to go back and try and see how we can arrive at this 0.25 if we start from scratch and we have no understanding of this rule. We are going to bang our head on the wall and try to figure it out on our own.